Okay, in this video we're going to review an algebra skill that's useful when trying to find the equation of a sphere, and that skill is completing the square. So here's a typical kind of problem you'd be asked. Find the center and radius of the sphere, and you're given this long equation. Okay, it's nice here they've told you that this is a sphere. If they haven't, the giveaways are that you have three variables here, x, y, and z. You've got the highest power being a 2, squared power, and no fractional powers. So you have some squared powers, you have some first powers, and then you have some constants. And that's it. And all of the coefficients of the square terms are the same. In this case, they're all 1, which is very nice. Okay. So in order to find the center and radius of the sphere, we're going to need to complete the square. So let's review how to do that. So there's our original problem, now in a slightly smaller font so that we can fit all the work on this slide. The first thing I'm going to do, gather all of my like terms. Right, so I have my x's together, I've left a little space, the y's together, left a little space, the z's together, left a little space, and I took the 1, okay, and subtracted it from both sides. So the constant term is now on the right-hand side. Now, this is quite a line right here. It's a lot less frightening than it appears. What you want to do with each one of these spaces that were in the second line is fill them in very specifically with half of the coefficient of the first degree term of, here in this group, the x to the first term. So half of -8, remember that negative is part of the number, so there's the -8, half of it divided by 2, and then we're going to square it. In the y terms, there's the y term right there. It's got a coefficient of 2, so we'll divide 2 by 2 and square that. And for the z terms, here's z right here. It's got a coefficient of 6. 6 divided by 2 squared. And since we've added 3 new things, 3 new numbers to the left-hand side of the equation, I'm going to add exactly those same 3 numbers to the right-hand side of the equation to keep everything equal. So just all I did here was simplify those fractions. Luckily, all of them even numbers divided by 2. So we've got that arithmetic done. And then what I'm going to do on the left-hand side is I'm going to take these terms 3 by 3. So here's all of the x squared, the -8x, and the -4 squared. Okay, that's a trinomial that I want to turn into a binomial squared. That's the square of completing the square. Right? And the reason I chose very carefully half of this -8 to be squared here is because then, when looking at this trinomial, it's very easy to figure out the binomial that's squared. There's the x, okay, and then this -4, which we'll write as -4, that's all squared. You'll see if you were to multiply that back out, right, you'd have a -4x twice, which would be the -8x we've got. Here with the y term, there's a y, there's a 1 on y plus 1 squared. The z's, there's a z, there's a 3 being squared, so there's z plus 3 quantity being squared. And over on the right-hand side, I began to neaten things up by actually squaring all of those numbers. Okay, and now the next line, I've added everything up on the right-hand side. I've got a 25. Okay, everything else on the left is easy. I've just copied it over again. And usually, a lot of times, when you get right-hand side looks like a perfect square, that's a hint that you probably did everything right, because that's the radius squared, and there's a reminder right there. Okay, so here's the definition of the equation of a sphere, what it looks like. If it's the center is the point HKL, the radius is R, then it has this form, right, with all these binomials squared. Notice the form here has minus signs in all of it, so we're going to have to flip those when we interpret if we have a plus sign. And remember that the right-hand side is the radius squared. So looking back at our original equation, not our original equation, after we've completed the square, the right-hand side's 25, so clearly the radius is 5. Okay, and then going through here, knowing that the general form has a minus sign in it, then the center is going to be 4. This is minus -1 make the plus. So -1 for the y coordinate, -3 for the z coordinate. That's what we have right there. And then if we're especially good at drawing skills, we may even get out a piece of paper and try to draw that sphere. Okay. So one other example of a slightly trickier one is this one here. It doesn't have quite as many terms in it, but notice what I've said at the beginning of the video, okay, that it's got x terms and y terms and z terms, nothing higher than a squared power. We have some squared powers. We have some first powers. We've got constants. This time the constants on the right to start out with. That's fine. Okay. And then we need to have the squared terms all need to have a common coefficient. In this case, it's 3. Okay, but it turns out that throws a little bit of a wrench in the process, because in order to get started with completing the square, we need the coefficients of the squared terms to be 1. So what I've done here is divided through the equation on both sides by 3, which for the most part was nice. We got integers on the way, but on the right-hand side we now have a 10/3. But not being afraid of fractions, we plow on. We group our x's, y's, and z's together with those spaces. Okay? And notice here that there is no x to the first term. There's just an x squared term. So we've really already completed the square for x. You're taking x and we're squaring it, or x minus 0, and we're squaring it, if you want to think of it that way. But we do need to still pick out the constants that we're going to square for the y and the z. Okay? So we're going to take half of the -2 here in front of the y and square it, so there's -2 squared. Take half of the -4 for the z, there's -4 squared. And of course, these two new terms we've added to the left, we also add to the right. Looking down a little further, okay. Kind of simplified what's in those fractions. Again, all of those are even numbers, which is nice. We divide by 2. Okay. And now we're going to gather our trinomials. Didn't have to really do anything with the x. I guess I could have written that as x minus 0, that quantity squared, to really drill it to my head that it fits the pattern, but I think I'll be able to keep track of that. Here's my trinomial in y. So there's the y, there's the -1, y minus 1 squared. There's the z, there's the -2, z minus 2 squared right there, and then we have a 10/3 plus a 1 and a 4. So I did that simplification on the right. I found the common denominator, which is 3, and added everything up, and I got 25/3. Okay, and so now I can tell you what the center is. Sorry, x isn't changed, so x minus 0. So 0 is the x coordinate, right? -1, -2. These fit the pattern with a minus sign, so we just have to pluck the 1 and the 2 there. So the center is 0, 1, 2. The radius is the square root of this number. The numerator, nice square root. The denominator, not so much. We'll just write it as 5 over root 3. If you'd like to rationalize the denominator, be my guest, but not a real need to do it in this problem. So here's just a rundown of the things you got to do to complete the square. Right, you're going to make sure the coefficient of each squared term is 1. If not, do what we did in that second example and divide through. Right? Move any constant terms to the right-hand side of the equation. Then group your variables together on the left-hand side, your x's, your y's, and z's together. Right, leaving space for that new constant term that you're going to be adding. Right, number 4. Okay, in that little space that you left, put half of the coefficient of just the first degree variable in there and square it. Okay. Make sure you also add those to the right-hand side at step 5. And step 6 says you've got some trinomials now that you can write as binomial squared. Do that. And add all together all the constants on the right-hand side, get a nice, neat right-hand side, and then use the general equation to find the radius and the center. Okay. And number 9, just a warning, because this is a mistake a lot of students make after all of that hard work and getting through, they write down whatever on the right-hand side as the radius and forget to take its square root. So make sure you do that. So that's all we have on completing the square. Enjoy.